Okay, so good afternoon, everyone. Welcome to Physics 71, and today our topic is on vector product and torque. Last time I discussed, ano ba diniscuss natin last time? Ang discuss natin last time ay energy in rotation. So we're still in the realm of rigid body dynamics and statics. We have considered rigid bodies, and we have obtained expressions for the energy of a body and for the rotational kinetic energy and the gravitational potential energy of a rigid body. So yun yung mga napag-usapan natin last time. Ngayon, of course, we have an analog of rotation for kinematics. So meron na tayong equations dyan. That's from lecture 20. We also have an analog for energy. So that's your rotational kinetic energy, gravitational potential energy, and so on. Now, the question now is, what about Newton's laws? So what about forces? Is there a rotational analog for force? So what causes an object to rotate? That's our main question for today. So, but before we go to that, let's go to one of the important products that we still haven't considered in vectors, which is the vector product or the cross product. So, kasi importante siya sa definition natin later. Okay, so here's an outline of this discussion. First, we discussed vector product or the cross product. So last time we discussed the dot product or the scalar product. Remember, for the scalar product, if you have two vectors, the product is a scalar. But on the other hand, you can also define another product wherein if you have two vectors, the product is another vector. So that's our notion of what the vector product is. I'll explain to you more on that as we go along. And then after that, we will be discussing torque. Torque is another, so remember you have our brake. Medyo magkatunog sila, brake and torque. The question now is, what does torque do? Anong ginagawa ng torque? If brake changes the speed of an object, what does torque do? Medyo magkaugnay ang dalawang yan. And kita mo, medyo related nga silang dalawa. We will see that as we go along. And then finally, we relate the torque of an object to the angular acceleration of a rotating body. And it turns out that there is an analog for Newton's second law, but now we are talking about rotational motion, not translational motion. So yun yung pag-uusapan natin for today. Okay, so here are the objectives of this session. At the end of this lecture, you should be able to first calculate the vector product or the cross product of two vectors. So again, medyo mas complicated mag-calculate ng vector product. Medyo hassle siya, pero pag-uusapan natin yan. And then we define what torque is. Torque is, again, the rotational analog of force. We relate torque to the angular acceleration of a body using Newton's second law for rotation. And that's it. Yun lang naman. And of course, we need to solve problems involving Newton's second law for rotation. That will be our basis for the best lecture ever, lecture 23A and lecture 23B. That will be discussed tomorrow and on Friday. Okay? Yun yung masasayang parts. Favorite ko yan. Okay, so first we discuss what vector product or the cross product. So there are two definitions. Remember, when we discuss our dot product, dalawa yung pinag-usapan natin. Yung isa, magnitude and direction form ang basis. Yung isa, unit vector form ang basis ng definition. So unahin natin for now para mas organized. Last time kasi inuna natin yung magnitude direction form. Ang unahin natin ay yung vector component for the vector product. So let's say you have two vectors A and B in their component form. So in general, these two vectors are in 3D. So A is some AXI hat plus AYJ hat plus AZK hat, and B is some BXI hat plus BYJ hat plus BZK hat. Then it turns out that the vector product, or we define the vector product or the cross product given by this long expression here. Ngayon, ang tanong mo, sir, paano kung akabisaduhin yung ganyang kahabang expression? Ganyan lang siya sinulat, pero it turns out may madaling way para malaman kung paano mag-calculate ng vector product. Kasi at the end of the day, kung ito ay face-to-face, so malamang sa malamang, di mo makakabisado yan, di ba? So, it's actually a determinant. So, how do we do? Of course, ayaw natin nag-memorize ng formulas. Ang gusto natin, nagpa-familiarize ng equations. So, let's say we have a matrix. Are you familiar with what matrices are? Familiar sa matrix?
Yes, sir.
Okay, I hope you're familiar with what matrices are. Basically, matrices are just an M by N matrix is just it looks like this. You have M columns and N rows, if I remember correctly. So this is, for example, an example of a 3 by 3 matrix. And when you determine the vector product, you're just basically determining the determinant of this matrix. Nagde-determinant ka lang dyan. So paano ginagawa? Okay, so let's say first we determine the first component or the I hat component. Ang gagawin mo, wag mo munang isipin yung ka-column at saka ka-row ni I. So si J at saka K, wala kang pakialam. At the same time, si AX at saka BX, wala ka rin pakialam. Ang tignan mo muna, itong maliit na 2x2 matrix na to. So may dalawang column and dalawang row. So it's a 2x2 matrix. And then what you will do is to multiply the first diagonal, the diagonal that is parallel to I hat. So pwede ka mag-create ng line dyan kung joining I hat. So yun yung unahin mo. You multiply it and then yung ka-diagonal niya, you also multiply and then you subtract. So you have AYBZ minus AZBY. Okay, just like this. You have AYBZ minus AZBY. Okay, nakuha? Nakuha gagawin? Tama? That's the first component. Again, ignore the x components. Tapos, multiply this, multiply that. You have AYBZ. Okay? And then after that, so the first component is AYBC minus AZBY quantity times I hat. Okay, so ganun yung gagawin mo when you calculate your vector product. Okay? Questions? May tanong? That's the first component. And so paano yung second component? Itong second component ay medyo iffy or medyo nakakalito. Kasi first thing, dapat may minus sign sa labas. Huwag kakalimutan na this is positive. The x component is positive, the y component is negative. Negative ng, so as I said, yung parallel, yung ka-column tsaka ka-row nung unit vector na kina-consider mo, ignore mo muna. So for example here, you ignore this parallel here, and then after that, what you will do is you perform the same thing. So yung magka-diagonal, AXBZ minus AZBX. So ganun yung gagawin. Ito muna, then tsaka ito. Okay, so this is AXBZ minus AZBX. Okay, nakuha? Nakukuha? Again, do not forget, this is negative. Marami na lilito dyan. This is negative. The y component is negative. Okay, clear? Clear ba? Okay, that's clear. I hope this is clear. And then finally, again, for the j component or j hat component, the negation is reversed. For the k hat component, again, ignore the columns related to k hat and the rows related to k hat. Tapos, ang gagawin mo, you multiply this and you multiply this, subtract them. Ganun lang gagawin. Lamurahin ko kasi may animation yan. You multiply again, subtract. Okay? Nakuha? Ganun lang gagawin when you compute your vector product. Questions? Questions? May tanong? Wala namang tanong? Okay, sige. Now, okay. That's the first way to calculate the vector product of two vectors. Now, of course, ang given sa atin ay I hat, j hat, and k hat components. What if we have a magnitude and direction? Actually, mas madali siya. Mas madali siya i-compute. So, the magnitude of the cross product between two vectors, this is the second definition. If you have two vectors, A and B, then the magnitude of the cross product is just given by magnitude. This is the magnitude, magkakalimutan. Ang cross product, yan ay vector. Therefore, kailangan mo maghanap ng direction. But for the meantime, ang magnitude ng cross product ay magnitude ng first vector times the magnitude of the second vector times the sine, not cosine, sine of the angle between them. So, kung naalala niyo sa dot product, ang hinahanap sa dot product ay cosine of the angle between them. What you want now is the perpendicular component, not the parallel component. So in that case, magnitude of A cross B is AB sine of the angle between them given by phi. Where again, phi here is the angle between A and B when connected tail to tail. Okay? Questions? So, again, magnitude pa lang yan. May way para maghanap ng direction. Don't worry. Questions? Nakuha? That's some definition? Okay, sige. Now, using this definition, pwede mong interpret yan. An interpretation is the magnitude of A times the component of B perpendicular to A. So, ang hinaharap na natin dito ay yung perpendicular component, not the parallel component. Compared when we compare it to the dot product. So, for the vector product or the cross product, ang kailangan natin ay yung perpendicular component. So, for example, here, if you have a vector, the magnitude of A or the length of A times the component of B that's perpendicular to the direction of A. So parang perpendicular. So when you draw it, parang nag-drawing ka ng perpendicular component dito, which is B sine phi, and that's what you will multiply by A. Okay? Nakuha? This is not the same as last time na nagbagsak ka ng shadow sa plane parallel to A. Hindi ganun yon. Ang ginagawa natin ngayon ay you have this this quantity that's perpendicular to E. Okay? Clear ba tayo dito? Clear? Is this clear?
Yes, sir.
Okay, sige. Now, another way to interpret is baliktad naman. So, the magnitude of B times component of A that's perpendicular to B. So, this is A cross B, which is B, times A sine C, where ang gagawin natin, magbabagsak tayo ng perpendicular component sa A, and A sine phi here is the component of A perpendicular to B. So, parang ganyan. So, ang ginawa natin, naghanap tayo, nagbagsak tayo ng perpendicular, and that length of that perpendicular is A sine phi. Okay? Questions? So, may tanong? Wala?
None, sir.
None. Okay, thank you. Sige. So, the direction, on the other hand, paano maghanap ng direction? Kung naalala nyo last time, when we discussed angular velocity, ang ginawa natin doon ay gumamit tayo ng right-hand rule to determine the direction of the angular velocity. Ganun din, in general, ang vector product. Kaya nga, when you go to higher mechanics classes, your angular velocity is actually a vector. It's actually a cross product. Okay, pero let's not go into that detail. Pero ang gagawin natin for the meantime is to use your right-hand rule to determine the cross product of two vectors. So, ibig sabihin, so for example, if you have, starting with A, turn towards B, and then the direction of the thumb is the direction of A cross B. Okay, so we can say that A cross B, or the cross product of A and B, is mutually perpendicular to both A and B. Kasi pwede ka mag-create ng, wala pa pala kay Math 22, no? So, pwede ka mag-create ng plane, of A and B, tapos yung perpendicular sa kanila, which is A cross B, that is a vector that's perpendicular to both A and B, or to the plane created by A and B. So yun yung ibig sabihin, other interpretation ng cross product. So again, you start with A, turn towards B, and the direction of the thumb is the direction of the cross product. On the other hand, ganito, mapapansin mo, if you start with B instead, turn towards A, the cross product becomes negative, or opposite the direction of the A cross B. Yung B cross A baliktad sa A cross B. Ibig sabihin nun, ang A cross B at B cross A hindi parehas. They're actually anti-commutative. Okay, sige. As I said, you place A and B tail to tail. You point fingers from A, palm towards B. The direction of the thumb is the direction of the cross product A cross B. Okay? Curl fingers towards B, thumb points in the direction of A cross B, and therefore, the order of the vectors matter because, as I said, kung B cross A yan, B cross with A, pababa ang direction ng cross product. Hindi siya same sa A cross B, backyard. Questions? May tanong? Questions? Ganun lang thank you. Ganun lang maghanap ng direction ng vector product. So, you use your right-hand rule. And usually naman for our problems, especially when you go to rotational dynamics, laging nasa positive Z or negative Z lang yung direction ng mga cross products na i-consider natin. So, medyo mas chill lang gumawa ng maghanap ng directions ng vector product. Okay? Sige. Now, some remarks. Again, huwag kakalimutan, the result or the A cross B or the vector product, the result of that is a vector, not a scalar. Pero dun sa second definition, inuna muna natin hanapin yung magnitude niya. Okay? But the direction, of course, can be obtained using the right hand. Second, the vector product is only defined in 3 dimensions. So there's a more general way to define a similar idea as the cross product, which is will natin pag-uusapan yun ngayon. But strictly speaking, the vector product is only defined in 3 dimensions, unlike the scalar product, which is defined for any finite dimension. In fact, even infinite dimensions pwede yan. Okay? Yun ang gustong sabihin dito. Yun muna yung gustong sabihin dito. And then, again, for the direction, you use your right hand rule. Okay, right hand rule lang yan pag naghanap ka ng direction. If the two vectors are on the plane of the paper or page, ito usually gagawin natin, use into the paper or out of the paper to indicate the 3rd dimension. So, for example, also you will see this a lot in Physics 72 in your EM class. Halimbawa, yung dalawang vectors ko nasa plane. Let's say this is A, this is B. So, I start with A. Sorry, sana kita pa rin kahit dun sa video. A, pointing towards B. And the direction is palabas. So this is out of the paper. On the other hand, B cross with A into the paper, yun yung magiging direction. So may conventions yan sa mga libro. The rotations are the following. Into the paper is across, a circle and closing across, and then out of the paper is a circle and closing a dot. Bakit? Kasi pwede mong isipin yan na arrow. Arrow yan eh. Bakit ang arrow ko? Ganyan na lang. Yan. Isipin mo, pag yung arrow ay naka-point sa'yo, ano nakikita mo? Di ba yung point lang niya sa harap? Tama? So, kaya out of the paper, kasi papunta sa'yo yung arrow. And hence, mukha siyang dot kapag tinignan mo. Yun yung ibig sabihin ng out of the paper dyan. Yung into the paper naman, pag nakabaliktad yung arrow, ano nakikita mo? Yung tail ng arrow, di ba? Kung nakita mo yung tail ng arrow, mukha siyang crossbound. Cross siya. Kaya may into the paper na ganyan yung notation. Clear? Clear ba? Questions? May questions ba dito?
Answer.
None. Okay. So, some other properties. The cross product of A with itself is 0. Anti-commutativity, again, based dun sa, kung nakita nyo naman, di ba, sa right-hand rule, A cross B is not the same as B cross A. It's actually the negative of B cross A. So, ingat sa kung ano yung mauuna dun sa operation. So, A ba o B muna yung mauuna. So, please take note of that. So, again, the order of the vectors matter. Scalar multiplication. So, pwede mong i-distribute yung scalar when you have a cross product. So, C multiplied by the expression A cross B is, you first scale C by some quantities. You first scale A by some quantity C, and then you can multiply it with B. Same thing with, you scale B by some C, and then you multiply it by E. Pero dapat ordering pa rin, tama pa rin yung ordering. And also, it's still distributive over addition of vectors. The cross product is distributive over addition. Okay, yan yung iba sa mga properties ng vector product. May mga tanong ba? Are there any questions? May tanong ba?
Answer.
None. Okay. So some coordinate notation, merong way para hindi kayo malito sa notations kasi sa dot product hindi ganun ka-complicated eh. Dito kasi parang I cross J, anong kailangan gawin? Ano yung mag-multiply? So, when you have unit vectors I, J, and K, ang arrangement ng ganito. So, meron ka, if you have I and J, ang cross product yan ay yung pangatlo, K. Tapos dapat tama yung pagkakasunod-sunod, I, J, K. So, I cross J is yung kasunod. K cross I is yung kasunod. J cross K is yung I. Okay? I cross J is K, K cross I is J. So, pag gumawa kayo ng diagram, dapat I, J, and K magkakasunod. Now, kung hindi ganun yung gagawin mo, edi kailangan mo maglagay ng negative. So, for example, what if I want I cross K? What is I cross K? Yeah? It is negative of K cross I because of your anti-commutativity. So I cross K is negative K cross I, and hence this should be negative J hat. So by anti-commutativity, kung if IJK is your counterclockwise direction, those in the operation that's counterclockwise, negative dapat yung magiging sagot na. So for example, J cross I, dahil baliktad siya dun sa notation natin, J cross I, ano yung nawawala? K. So dapat K yung sagot niya, pero since baliktad siya, maglalagay ka ng negative sign. So we have J cross I is minus K hat. And further, K cross J, baliktad again siya. Ang nawawala dun sa K cross J ay I. So K cross J is I, pero kailangan may negative sign. So this should be minus I hat. And then also, I cross K, ang nawawala ay J, pero since baliktad siya, you have minus J hat. Okay? Huwag malilito. Ang gagawin nyo lang, when you draw it, I, J, K, lagyan nyo ng arrows. From I to J, J to K, and K to I. And then when you cross product that, pag sumunod sa flow nung drawing nyo, positive. Pag anti-parallel or pag baliktad yung direction, negative. Okay? Questions? May tanong? Ganun lang yon. Ganun lang when you use your unit vectors in determining the cross product. Sir, paano yung I cross I? J cross J, K cross K. Yun, zero dapat yun. It should be 0. Again, the cross product of a unit vector or any vector with itself is 0. Okay? Questions? May tanong?
None, sir.
Okay.